Hello, good day. In this video, we are going to learn about binomial option pricing model, which is an important and useful tool for option valuation. There are two types of models covered in this video, the one-step and two-step binomial models. We will use the models to value call option, put option, as well as European and American options. The mathematical model and formula may look complicated for ordinary investors on the street. However, if your theoretical concepts are strong and you understand well how options work, I'm sure you can master these valuation skills. Practice makes perfect too. Let's learn together. The binomial option pricing model is developed by Coase, Rose, and Robinson in 1979. It is an option valuation method. The model assumes that the underlying security prices can only either increase or decrease with time until the option expires or lost. Binomial option pricing model is a graphical representation of possible future values. It shows the possible future share prices as well as the intrinsic values that an option may take at different nodes or time periods. The binomial tree shows the different possible paths that might be followed by the underlying stock price over the life of the option. The model assumes a discrete time period. At the end of the period, the stock prices can be higher or lower than at the start of the period. This slide shows the key symbols and formula for the one-step binomial model. S0 refers to the stock price at time 0. U means upside change, and D stands for downside change. SU is the share price with upside change. SD is the share price with downside change. F stands for the value of option. P stands for risk-neutral probability. I will explain further about risk-neutral probability in the next slide. There are two sets of formula listed for the calculation of option value, F. Both formulas are highlighted in pink color. Why is that so? Do you know the difference between the two formulas for F? Well, the first formula on the bottom left of the slide is used with assumption of continuous compounding. The expected value of option in future is discounted with e power of negative RT. The second formula on the bottom right of the slide assumes discrete compounding. The expected value of the option in future is discounted with 1 plus interest rate. To sum up, the option value is the present value of future expected value of the option, considering both the probability of upside and downside change. What is a risk-neutral probability? The risk-neutral probability is represented by symbol P. The risk-neutral probability is based on three assumptions. First, investors are indifferent about risk. Second, the expected return on the stock is equal to the risk-free rate of interest, which is very minimal. Third, the market is in equilibrium. There is no opportunity for arbitrage. Why is the formula of risk-neutral probability is as such? How is the formula developed? We are going to understand further. For continuous compounding, the future value is equal to present value multiplied with exponential compounding factor e power of r and t. The expected return can be explained in two ways. First, if we assume investors will earn a risk-free rate of return, the expected return is e power of RT. Second, the expected return is also the weighted average of the probability of upside and downside change. Both the explanations of the expected return can be combined into an equation as highlighted in yellow. When we rearrange the equation and solve for P, we shall obtain the final formula for risk-neutral probability, which is highlighted in pink. The steps for option valuation using a binomial tree can be summarized as follows. First, create the binomial price tree. From share price at time 0, S0, forecast the SU and SD based on upside and downside change. Second, compare the SU and SD with the exercise price of the option and find the intrinsic value of the option at each final node. This means find the FU and FD. Third, from FU and FD, find the option value F at earlier node by using discounting methodology. Let's look into an example. We shall value a call option. A 3-month European call option on the stock has a strike price of $21. The risk-free rate is 12%. The upside and downside change is 10%. The current stock price is $20. With upside change of 10%, the current stock price of $20 times 1.1 will give us $22. On the other hand, with downside change of 10%, the current stock price of $20 times 0.9 will give us $18. When the share price is $22, the call option is in the money. The intrinsic value is $22 minus exercise price of $21, and the intrinsic value of the call is $1. When the share price is $18, the call option is out of the money. The intrinsic value is 0. Our objective is to calculate what is the value of the call option today at time 0. This slide briefly explains the background of the example. I would strongly encourage you to read through. The calculation of the value of the call option are summarized in this slide. First, you can make use of the risk-neutral probability formula to calculate P. P is equal to 0.6523. Therefore, 1 minus P is equal to 0.3477. Next, you can make use of the option formula to calculate F, which is the value of the call option. Now I'm going to show you how to make use of Excel to build a binomial tree for call option valuation. First, I'm going to type the formula for risk-neutral probability. The formula is shown here. I'm going to type equal EXP, open bracket, then I point the risk-free rate of 12%, multiply with the time, which is 3 months or 0.25 year, close bracket, minus the downside change of 0.9. After that, I put a big bracket in front, then divide by open bracket, U minus D, close bracket, enter, and the answer for risk-neutral probability is 0.6523. Next, I'm going to calculate 1 minus P, which is equal to 1 minus this value. Enter, and I obtain 0.3477. The current share price is $20. 3 months later, with upside of 1.1, the share price will be equal 20 times 1.1. Enter, which is $22. If the downside is 0.9, the share price will be equal 20 times 0.9, and the value is 18. this is a binomial tree that I have built. Next, I'm going to build a binomial tree for the option. I'm going to start from the final node here. I shall type equal maximum max open bracket, then I point the stop price minus the exercise price, comma, 0, close bracket. Take note that I fixed the reference cell for the exercise price. I type F4 here to fix the reference cell. Enter. The value of the option is 1. The option is in the money when the market price of $22 is higher than the exercise price of $21. I can drag this down to obtain another value. Alright. After that, I can make use of the option formula here to calculate the value of the option. I'm going to type equal exp open bracket negative of risk-free rate multiply with time, which is 0.25, close bracket, multiply with open bracket, point the risk neutral probability, multiply with FU. FU is here 1. Then add 1 minus probability, multiply with FD, which is here. After that, I press close bracket and enter. And this is the value of the call option. This value is obtained from discounting. Next, we are going to learn how to construct a two-step binomial model for option valuation. You can make use of the formula given in the slide or use the original one-step binomial formula and repeat the process twice at the first node and second node of the binomial tree. I will show you how. Let's look into an example. Here the original stock price is $20. The upside change and downside change is 10%. Here we assume there are two nodes to the binomial tree. In this example, we assume the risk-free interest rate is 12%, the strike price is $21, and each time step is 3 months long. Let me show you how to construct a two-step binomial tree using Excel modeling. The original stock price is $20. With upside of 1.1, I shall type equal the original stock price times 1.1, I point here, and I'm going to fix the reference cell here by typing F4. Alright, the downside change is 0.9. I'm going to type equal, point this cell times 0.9. I'm going to fix the reference cell for 0.92 by typing F4. Enter. After that, I can drag this to the right. Alright, and also drag this to the right and drag down the answer. Okay, so I have obtained the stock prices at the first node and second node. Next, I will show you how to construct the binomial tree for the option. I shall start from the final node here. I'm going to type equal max. Max stands for maximum of stock price minus strike price, comma 0, close bracket. Take note that I will fix the reference cell for the strike price. Enter. The value is 3.2. This means the option is in the money when the market price is higher than the strike price. I can drag all the way down to obtain the rest of the answer. The option is out of money when the market price is 19.8. The option is also out of money when the market price is 16.2. Therefore, the value is 0. Next, I'm going to make use of this formula here to calculate the value of the option. This is a one-step binomial formula. I'm going to type equal exp, open bracket, negative of risk-free rate times time to expiration of 0.25, close bracket, times open bracket, p times fu, which is cell E19 plus 1 minus p times cell E20, close bracket, and take note that I will fix the reference cell for the interest rate, the time, the p, and the 1 minus p. Enter, and this is the value for the option using this set of data here. I'm going to drag this down, alright, and drag to the left to obtain the rest of the answer automatically. I do not need to retype again. I just need to copy and paste across the value. This value is obtained from this cell. This value is obtained from all these cells, as you can see from the highlighted color. The value of the call option is 1.28. Alternatively, the value of call can be obtained using two-step formula. This is the formula to use. You can substitute the value accordingly and find the value of the call option, which is 1.28. This slide shows the details of the manual working and calculation using formula. You may read for more detailed understanding and try on your own. I find using Excel modeling extremely useful as compared with manual calculation using formula and calculator. Anyway, you may try to verify the answer. The answer should be the same. Next, we are going to learn how to value a put option. The steps for valuing put options using a binomial model is the same as valuing call. Take note that a put option gives the holder the right to sell the underlying asset at the stated strike price within a certain time period. If the market price of the underlying asset decreases, then investor can make a profit from the put option. In this example, consider a 2-year European put option with a strike price of $52. The current stock price is $50. The stock price is expected to move up or down by 20%. The risk-free interest rate is 5%. Let's calculate the value of the put option. In this Excel spreadsheet, I'm going to show you how to calculate the value of a put option using a two-step binomial model. The current stock price is $50. The upside change is 20%, therefore the value is 1.2 here. The downside change is also 20%, and the value is 1 minus 0.2, which is 0.8. I'm going to make use of the upside and downside change to calculate the future stock price. I'm going to type equal current stock price times 1.2. And I'm going to fix the reference cell here by typing F4. Enter. Next, I'm going to calculate the future stock price based on downside change of 0.8. I shall type equal point 50 multiply with 0.8 and fix the reference cell. Enter. Next, I can just drag the value across. Alright, I drag this across and drag this down too. And the stock price in 1 year and 2 years are shown here. Next, I'm going to show you how to construct the binomial tree for the put option. At expiration date, the value of the put option is either in the money or out of the money. I'm going to type equal MAX maximum, open bracket, strike price minus market price, comma, 0, close bracket, and I'm going to fix the reference cell for the strike price by typing F4 here. Enter, and the option is out of money because the market price is higher than the strike price. I can drag this cursor down here to obtain the rest of the value. At market price of $48, the option is in the money because the market price is lower than the strike price. The intrinsic value is 4. When market price dropped to 32, the value of the option is even higher. Next, I'm going to calculate the value of the option in 1 year period. I'm going to make use of this formula here. I shall type equal EXP, open bracket, negative of the interest rate, multiply with time period, which is 1 year, close bracket, multiply with open bracket, risk neutral probability times option value, which is cell L19. Then add 1 minus probability times the option value, which is cell L20. Close bracket, enter, and I obtain the value of the option here. Take note that I should fix the reference cell for interest rate by typing F4, fix the reference cell for the time period, fix the reference cell for the risk neutral probability, as well as fix the reference cell for 1 minus P. Enter, and this is the value. Next, I can drag the value down, alright, to obtain another value here. I can also put my cursor here and drag to the left and obtain another value here. So the value of the put option is $4.19. For your convenience, this slide shows the summary of the two-step binomial tree. The stock price changes by 20% at end of year 1 and end of year 2. At expiration at end of year 2, the put option is in the money when the market price is below the strike price of $52. The value at time 1 and time 0 is calculated using the option formula. If you like manual calculation, you may try this. This slide summarizes the detailed working and calculation using a two-step formula. The answer is the same as the Excel modeling which I have shown you. In this slide, a two-step formula is used directly. I use a one-step formula when constructing my Excel modeling. Anyway, the answer is the same. This slide shows the working using the one-step formula. The results can also be obtained by working back through the tree one step at a time. Next, we are going to learn how to value an American option. Take note of the key difference between European and American option. And European options can be exercised on the expiration date, while American options can be exercised anytime up to the expiration date. Therefore, the valuation of American option is slightly different. The procedure is to work back through the tree from the end to the beginning, testing at each node to see whether early exercise is optimal. The value of the option at the final nodes is the same as for the European option. The values for the option at the final notes are also unchanged. At earlier notes, the value of the option is the greater of the value given by the equation or the payoff from early exercise. The stock price and their probabilities are unchanged. Let's consider the same example for a 2-year put option. From the two figures, what are the key differences? Do you notice the difference? Well, the market prices of the stock and the possible changes in year 1 and year 2 are the same. The values of the option at expiration date are the same. The only difference is at Note C, where the option value is $12 instead of 9.4636. Why is that so? This is because at Note C, the put option is in the money and it will be exercised. At Note C, the intrinsic value of the put option is the strike price of $52 minus the market price of $40, and the intrinsic value is $12. The value of the put option at time 0 is higher for American option, as we discount higher values at Note B and Note C to obtain the value of the put option at time 0. The American put option is worth more than the European put option. Now I'm going to show you how to model an American option. We are going to use the same example as the put option. This is a two-step binomial model. The share price movement here. Alright, and the value of the option at expiration are the same as European option, which I have calculated earlier. The only uniqueness of the model is here. How to calculate the value of the put option when this is an American option. I'm going to show you now. I shall type equal max for maximum, open bracket, then I type exp, alright, for exponential, open bracket, negative of risk-free rate times 1 year period, close bracket, then multiply with open bracket, point the risk neutral probability times option value as cell S19, okay, then plus 1 minus P times option value as cell S20, okay, then close bracket, comma, strike price minus the market price here, and close bracket. You can look at the reference cell. Take note that I shall actually fix the reference cell for the risk-free rate, for the time period, for the P, for the 1 minus P, as well as for the strike price. Okay, enter. Then this is the value of the option at the end of year 1. You can look at the reference cell for the input, for the share price, as well as for the put value on expiration date. Next, I'm going to put my cursor here and drag this figure down. Alright, and the value is $12. I'm going to put my cursor here again and drag to the left. Alright, and the value is 5.09. You can see from the reference cell that the input come from here, come from the market price of 40 and the option value of 4 and 20. Alright, take note that this value is $12 because this is the intrinsic value. The option is in the money and will be exercised. Therefore, we take the intrinsic value. This value is obtained from the following inputs based on the market price of 50 and the two option value here. Finally, the answer for the put option when this is an American option is 5.09. This slide shows the manual working, calculation, and detailed explanation. You can verify the answer with the Excel model. The answer is the same. Finally, we have come to the end of this video. This video is slightly longer than my usual recording. I hope you will practice the examples on your own. The key lesson is the formula may seem complicated, but if your theoretical concept is strong and you understand well how options work, then you won't go wrong. Last but not least, practice makes perfect. See you and goodbye.